Okay, so what we've got is a servo motor here and a potentiometer. And as I move the potentiometer, it's moving the servo motor. But the most important thing that I want you to notice is the pulses going on the screen here. So you can see that these pulses are taken from the Arduino to the microcontroller. So the picoscope is set to 2 milliseconds per division. So when it's at that, it's about 1 millisecond per division. When it's over to here, it's about 2 milliseconds per division. And that tells the servo motor at which position to go to. So you can see that the pulses and the servo motor are synchronized, and that's how the information gets from the Arduino to the servo motor. Okay. Moving on to the next one, what I've got is a bend sensor, and all this does is it changes its resistance as I bend it. So the resistance between these two pins changes. What I've done is I've put it over a voltage divider, and it's voltage going into the Arduino, and what we've got is raw data coming in. So as I bend it, you can see it goes a high number, and as I flatten it, it goes to a lower number. Obviously that's not calibrated, that's just A to D values, but it could be calibrated to bend. That's something you'd have to work on yourselves. Moving on to the next one, if we go to the far screen over here, so what we've got is a distance sensor. So if we have a look at here, we can see as I move my hands up and as I'm moving my hand there, we've got distance in centimeters. So close and far away, like that. But how this distance sensor is communicating to the Arduino, if you look on this screen, is as I move my hand closer, it's a short pulse, so that's 1 millisecond per division, so that's about 1 millisecond. And as I move my hand further away, 2 milliseconds, and further away, 3 milliseconds, and the Arduino is simply counting how long that pulse is and converting it into a distance. That's exactly what's going on there. Okay. If we move on to this one, we've got transmission and reception of data. And what I've got here is I can send some information over here and press a value. It then gets sent over these wires to the receiving one. And you should be able to see that, well, I sent hello, and then it should send it, you should see it there. I'm just going to look at this. Okay. And at the same time, if I send that data again, so if I just send some characters, a load of capital A's, if you just have a look on this one, and if you're quick, you'll see that the data has gone through there. I sent a load of capital A's, so they were all the same. You might have noticed that there was a bit of a repetition in the data there. You can see it going through, and that's the ASCII data being tapped from these lines, and that's how line tapping works. So these wires are receiving the data. You could interpret that from the ASCII values, the binary into the ASCII, and then reconstitute the data. And of course on that receiving one you should get a load of A's as well, so that was being sent. So this is how you would snoop in on information. Okay, and then the last one over here, what we've got is a GPS receiver outside. It's just RS-232 data coming through at a baud rate of 4,800. And what we've got is if I just scroll that, you can see live data coming through from the GPS satellites. Now there's lots of different data strings here, but the main one which we're interested in is this GPRMC, which tells you the time of day, so it's 8, 58 and 43 seconds, that's GMT. And then we've got 5246.9108, that's your latitude, N, northern hemisphere, and then you've got your longitude, and then west of Greenwich. So your data is moving from your GPS receiver in real time, and then it can be converted. Just something to show you as well, notice that it's at 4,800 baud. If I got the wrong baud rate, let's say 9,600, and try to look at the data, you can see that it looks like a load of what I call gobbledygook, probably not a technical term. But if you don't have the right baud rate, so if I do too slow, you'll always get rubbish. You have to make sure that you match the baud rate. The data sheet of the sensor told me what the baud rate was, and then I set it to 4,800. That's a lot. Thank you very much.